My name is Cynthia Hall, and I'm the Community Coordinator for NASA's Earth Science Data Systems program. Our program wants to make sure you have everything you need to access the petabytes of free and open Earth science data from NASA.
When most people hear NASA, they think of space, not Earth. But NASA's Earth Science Division uses the vantage of space to study the Earth processes that power climate, weather, and natural hazards, and the impact of those processes on life on Earth. NASA gathers information about the Earth from a fleet of Earth-observing satellites. This fleet of satellites allows NASA to gather information about the whole Earth system. NASA collects the data through its orbital, airborne, and field programs. Data include measurements that inform us about processes in the atmosphere, on land, in our oceans, and more. The Earth Science Data Systems program actively manages NASA's Earth Science data to develop data systems capabilities that support rigorous science, as well as interdisciplinary research, applications use, and even commercial or public use. Within NASA's Earth Science Data Systems, open source science serves as the foundation of the program. That is, the open sharing of data, information, and knowledge with the scientific and application communities and the wider public so that we can accelerate scientific research and understanding around the world. NASA open data policies are helping break down barriers to using NASA Earth Science data and foster a more collaborative, inclusive scientific process open to anyone, regardless of background, ethnicity, gender, or geographic location. Our activities support the open source science ecosystem and its core principles, shortening the time it takes for a new user to find and learn how to use data, increasing the community contributions by allowing for integration of data, exploring and exploiting data in new ways such as geospatial web services, interactive web apps and applications, and more. Although the data are freely available and there are multiple entry points to the data, promoting this open access and use, data users still have challenges. First, where to get started, and then which dataset to select once at an entry point. It is critical that we provide a roadmap or pathway to relevant data and applications for specific investigations. NASA Data Pathfinders help do just that. Pathfinders are data product selection guides focused on science disciplines and application areas, providing information on specific and relevant measurements with information about spatial and temporal resolution. They have direct links to commonly used datasets across NASA's Earth Science collections. And finally, they link to tools which provide ways of visualizing, subsetting, and analyzing the data. Currently, we have Pathfinders on a variety of thematic topics. However, today I will focus on our disaster series. This series includes data and resources for tropical cyclones, earthquakes and volcanoes, extreme heat, flooding, landslides, and wildfires. And then I would like to quickly show our GIS, or Geographical Information System, Data Pathfinder, if you are interested in accessing GIS-ready data from NASA. So here we are at earthdata.nasa.gov. In the Learn section on the Earth Data website, we provide a bunch of great resources to help you get started with remote sensing data. These include backgrounders like What is Remote Sensing?, a resource for those new to satellite or airborne observations. This backgrounder provides information on types of orbits, the electromagnetic spectrum, the different kinds of sensors that are used, different resolutions like spectral, spatial, and temporal, and then finally, information on data processing and interpretation. Our most recent backgrounder is Nighttime Lights, and it provides information on the Visible Infrared Imaging Radiometer Suite, or VIIRS instruments, aboard the joint NASA-NOAA SWAMI NPP and NOAA-20 satellites. The VIIRS day-night band data are used for estimating population, assessing electrification of remote areas, monitoring disasters and conflict, and understanding biological impacts of increased light pollution. Back at the Earth Data site under Learn are also Pathfinders. You can see here all of the applicable Pathfinders. Today, I'd like to focus on disasters. Each Pathfinder has an About the Data section, which provides information about every dataset in the Pathfinder. The section provides the measurement taken by each of the sensors, as well as the spatial and temporal resolution. This information is useful when determining which data set to use in your research, whether that be knowing the scale at which you need data, as well as knowing if the data are available in the time frame of interest, daily versus every 16 days, for example. Use the Data provides information on how the data are currently being used for planning and decision making. It provides real-world examples of data in action. The Benefits and Limitations section provides insight into considerations when determining whether or not to use remote sensing data. And lastly, each Pathfinder has associated resources, both from NASA as well as outside sources. It is important to note that NASA enables research. The agency does not participate in disaster-related operations, yet many of the research capabilities developed at NASA have been transitioned to operational agencies such as NOAA, the National Hurricane Center, the USGS, and other agencies, many of which are included. Let's dive further into cyclones. In this example, we have several sections that provide those direct links to commonly used datasets: observations when assessing the conditions just prior to an event, near real-time data, and assessing post-storm impacts. Pre-storm assessment contains measurements such as precipitation, relative humidity, sea surface temperature, winds, and sea level pressure. Near real-time assessment provides data sets, many of those mentioned before, but often available as soon as 3 hours from satellite overpass. Post-storm assessment provides measurements that aided flood inundation mapping like surface reflectance or synthetic aperture radar, soil moisture, and nighttime lights to assess power outages. If we go back, let's take a look at earthquakes and volcanoes. You can see the layout is similar, but obviously this one provides different types of data scenarios. We provide direct access to Global Navigation Satellite System, or GNSS, data, which can be used to determine how stations near active faults move relative to one another. We have disaster response, like NASA's ARIA project, which for certain events produces damage proxy maps, depicting areas that are likely damaged, as well as regional displacement maps, or links to NASA's disaster mapping portal. There are also data for volcanic aerosols like sulfur dioxide, data for visualizing eruption plumes. Nighttime lights can be used to provide an assessment of power outages. And lastly, the post-assessment data provides information on synthetic aperture radar, or SAR, which can be used to generate interferograms that show land displacement.
The Pathfinders also provide a section on tools for data access and visualization, with a brief introduction to each tool within the Pathfinder, including tools from the Earth Observing System Data and Information System, or EOSTIS, from the Distributed Active Archive Centers, or DACs, as well as from partner agencies when applicable. Links to webinars or tutorials on using the tools are provided for you to delve deeper. Earth Data Search is a tool for data discovery of NASA's Earth observation data collections. Users, including those without specific knowledge of the data, can search for and read about the different data collections. I can type my keyword directly into the search box, or I can choose from a list of keywords. I can also search by platform, instrument, organization, processing level, and so on. For example, if I know I want MODIS ocean color data, I can type in ocean color and select MODIS from my list of instruments, and all of the relevant data collections are shown. I can further filter by searching for data files by date, spatial area. I can preview, browse images, and then download or submit requests for data files with customization for select data collections. Worldview is a visualization application that provides the capability to interactively browse full resolution satellite imagery layers and then download the underlying data. Many of the available imagery layers are updated within 3 hours of observation, essentially showing the Earth as it looks right now.
For example, this data was collected on July 22nd of 2020.
And as the data become available, they are added into Worldview. This supports time-critical application areas. You can add layers via hazards and disasters thematic areas or by science disciplines. Let's say I want to look at ecological data. I can go to Biosphere, select a data set of choice. I'm going to select amphibian richness, all threatened species. This data set provides information on the number of threatened amphibian species present at a 1 kilometer spatial resolution, which can be used in modeling efforts, wildlife conservation planning, natural resource management, policymaking, biodiversity studies, and human-environment interactions.
If you are looking for NASA data that can be incorporated easily into a GIS, check out our GIS Data Pathfinder. Here, we provide a variety of topical information. For example, working with multidimensional data in a GIS, using NASA data in a GIS. This includes how to add raster or vector layers, as well as how to add a web map service. NASA's ArcGIS DAC collaboration is producing a series of GIS-ready content which incorporate NASA Earth observations from multiple NASA applications into single thematic web maps and applications. Drought is the first in a series. Additional themes will include floods, air quality, and more. And users can interactively explore this data. We also have several use cases for integrating NASA web services. For example, maybe you are concerned about a changing climate. You can conduct an analysis of coastal wetlands loss from sea level rise using estimates of wetland losses as a basis for identifying potential adaptation measures. Through the Socioeconomic Data and Applications Center's web coverage service, you can directly access elevation data, population density, and urban extents grid within your GIS. Some of NASA's DACs provide geospatial services, specifically web map services, web map tile services, web feature services, and web coverage services, providing access to a variety of GIS-ready datasets. Each section here provides the datasets available for a given topic and the DAC responsible for the geospatial service. If I go back to the main GIS Data Pathfinder page, we also have a list of tools for discovering NASA GIS-ready data. NASA ArcGIS Online, as well as tools from the DACs. Within the DACs, data can be visualized, subsetted, and downloaded in different file formats that are GIS-ready. The table contains a list of tools with the datasets that are available through the tool. Once you know the dataset of interest, link to the tools and a brief tutorial on using the tool are provided. NASA Earth Data's wealth of data discovery and data access resources, such as the Data Pathfinders and the Backgrounders, are designed to help you find, access, and use NASA Earth science data that can help in your research or your organization's decision-making process. These data are yours to use freely and without restriction. Please come explore all of our resources at earthdata.nasa.gov. Thank you for your time.